Hey everybody, welcome to 5.5, the Triangle Inequality Notes. In this video, we're going to talk about, the Triangle Inequality. So the Triangle Inequality, in short, states that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So what it means is, if I add together this side and this side, whatever the lengths are, it should be greater than whatever this is. And then any two sides. So PR plus QR should be greater than PQ. QR plus PQ greater than QR. PQ greater than PR greater than QR. So any combination, it should always be greater than that. So here I have three side lengths of 8, 15, and 17. You're going to tell me if that can make a triangle or not. So all we do is we write 8 plus 15, and is that greater than 17? Yes, it is. 8 plus 15 is 23, so 23 is greater than 17. Next, I'll do, 8 plus 17. So I'll say 8 plus 17, is that greater than 15? And 8 plus 17 is 25, so 25 is greater than 15. Lastly, I'll just take my 15 and 17 and determine if that is greater than 8. So 15 plus 17, is that greater than 8? Yes, it is. 15 plus 17 is, 32? So 32 is definitely greater than 8. So if they all work out greater than, then yes, it can make a triangle. So here in example B, I have 6, 8, and 14. So I'll do 6 plus 8, and is that greater than 14? Well, 6 plus 8 is 14, so you have 14 equals 14. So that's not going to work. Now, the other two inequalities will work. 6 plus 14 is greater than 8, and 8 plus 14 is greater than 6, but they all three need to be greater than. So if you ever have a sum that is less than the third side or equal to that third side, then it is no, it will not be able to make a triangle. So you can use the triangle inequality to figure out a possible value for a third side of a triangle when given only two sides of the triangle. And what I mean by a possible value is you can use this triangle inequality to figure out a range of values, because you can make a triangle, there's an infinite number of combinations out there to make triangles. As long as your three sides fit that triangle inequality that we just did, then it works. So if I have a triangle that has 3 and 7 for its two known sides, then there are multiple answers that can be for that third side. So you'd use that triangle inequality to figure out what the possible values could be. So it's going to be the same thing as the other examples, where I'm going to go 3 plus x, is that greater than 7? Then I'll go 7 plus x, is that greater than 3? And then I'll go 3 plus 7, is that greater than x? So I have those three inequalities set up here. All you need to do is just solve each for x. So like this first one, 3 plus 7, that's 10. This says 10 is greater than x. If you want, you can rewrite it from x's perspective. It'll say x is less than 10. Doesn't really matter. And then moving on to the other one, if I just minus 3 to the other side, I have x is greater than 7 minus 3 is 4. And then the third example, I have x plus 7 is greater than 3. If you minus 7 to the other side, you get x is greater than negative 4. Now, if you have a negative solution, you can just go ahead and ignore it. I wrote that down right here. Throw out any negative solutions, because you can't possibly have any negative side lengths in a triangle. So what this is saying is x is going to be less than 10, but greater than 4. So you take those two and you put them together to rewrite it as a compound inequality. You put x in the middle, and so if x is greater than 4, you're going to write it backwards as 4 is less than x, and then x is less than 10, so you're just going to tack it on to the other side. And so this compound inequality is going to state your range of values that third side could be. What it's saying is x is in between 4 and 10. But you can't equal 4 and 10. Notice how these are strictly less than signs or strictly greater than, whatever way you're reading it. X is strictly greater than 4. So that means 5, 6, 7, 8, 9, 10 or whatever. But it's also less than 10. So 9, 8, 7, 6. So in between 4 and 10, your values are 5, 6, 7, 8, or 9. Because you can't equal 4 and you can't equal 10. So as a follow-up question, I ask, what is the smallest possible whole number measure and what's the largest possible whole number measure? Like I said, since you can't equal 4 and you can't equal 10, the next biggest number from 4 would be 5. So I could equal 5 feet for the smallest possible value of that third side. And then the largest possible value of that side would be 9 feet because the limit is 10, but you can't equal 10. So the next closest whole number to 10 would be 9. So if you want to think about it like this, just go one bigger than 4 and then one less than 10. And you can apply that same pattern for any other problem. So I added this note to my notes. I don't know if you can read this, but I wrote, if you notice, the number on the left is 7 minus 3. That's the 4. And the number on the right is 7 plus 3. That's the 10. You can apply this pattern to any problem like this, and it will go way faster. So what I mean is, instead of doing these 3 inequalities, if you're given 2 of your sides, you can just subtract them. Just make sure you do it in the correct order. Do the bigger number minus the smaller number so you don't accidentally write down a negative side length. So I'm going to do 7 minus 3, not 3 minus 7. So 7 minus 3 is 4. 7 plus 3 is 10. So my answer is between 4 and 10. And it's always going to be written as a compound inequality like this. So I'm going to apply that same kind of method to this. I have a triangle where 2 of the sides are 13 centimeters and 9 centimeters. So I'm just going to do 13 minus 9, and 13 minus 9 is 4 centimeters, and 13 plus 9 is 22 centimeters. So my range of possible values is going to be in between 4 and 22. So you can just say 4, put an X in the middle, and then a 22. Make sure your inequality signs are pointing to the left, okay? Doesn't make sense if they point to the right. So this is actually the answer, all right? Notice how it was way quicker than doing setting up 3 inequalities, and then even though they're simple inequalities to solve, it's still way faster. So for my smallest possible whole number measure, that's going to be 1 bigger than 4, so that's going to be 5 centimeters. And then the largest possible number will be 1 less than 22, since I can't equal 4 or 22, right? That's why I'm picking these numbers. So I'm going to say 21 centimeters. So if I could only use whole numbers, that's telling me I can use 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. Any of those numbers would make a good third side, and it'd make a triangle. If I used a number like 4 or less, or 22 or greater, what you'd have is you'd have a triangle where 2 of the sides are like too short and they couldn't touch. All right. All the other ones, they'd have the third side would touch, and it'd make an acute, obtuse, or maybe even a right triangle. So that's going to draw these notes to a close. Thank you for watching. Hope these helped, and goodbye.